Hi guys, so today we're going to be learning about classifying angles, and there are two main ways that we classify our triangles. One is by the angle measure, and then the other one is based on how many congruent sides it has. Okay? So if you look at 4-1 here, it tells us how we classify triangles by angles. Our first triangle is the acute triangle, and in order to be acute, all of the angles must be acute, which means that all of the angle must measure less than 90 degrees. Okay? In an obtuse triangle, one of the angles is obtuse, which means that one of the angles measures greater than 90 degrees. The other two, in order to add up to 180 for our triangle, will have to be acute. Okay? So with an obtuse triangle, only one of them is obtuse. The other two are acute. In a right triangle, one angle is right, or one angle measures 90 degrees, and then the other are acute. Okay? So note that there are acute angles in both obtuse and right triangles. However, the thing that makes an acute triangle acute is that all of them are smaller than 90. Okay? And then also we have a special type of acute triangle, which is the equiangular triangle. And that is when all of the angles are equal to each other, and that's when all of them are 60 degrees. Okay, so a more specific type of acute triangle is an equiangular triangle, which only happens when the angles are equal. So we're going to start with example 1 here. We're going to classify this triangle by angles. So here, the roof of this house is made up of 3 different triangles, 1, 2, and then 3 here. We're going to use a protractor to classify this angle and measure it as either acute, equiangular, obtuse, or right. Okay? So I'm going to start by measuring angle D here. So I'm going to match up my vertex to the cross or the circle or whatever we have here. Okay, and then here it is pointing at 50 degrees, right? A better way to measure it is to connect it further. And then that's when you'll get your most accurate reading. So it's basically at 50, right? So angle D here is 50 degrees. And then I'm going to measure the rest of them. Okay, so I have each of these measured. This is 90 degrees, 90 degrees, 50 degrees, 40 degrees, 40 degrees. So that means this total here would be 80. Okay, so the first angle triangle here is DFH. This is this big one, right? And so if it's 50, 80, and 50, all of those are acute angles. So angle DFH would be an acute triangle. The next one here is DFG. So DFG is this one here on the right. Okay, so then it's 40, 50, and 90. And then because there's one 90-degree angle, that would make DFG a right triangle. And then the other one is HFG, which is this one. So that's 40, 90, and 50. And so this HFG, because of the 190-degree angle, it would be a right triangle. In this case, there is no equiangular triangle because none of them have 60 degrees for each angle, and then none of them were bigger than 90 degrees, so none of them are obtuse. Okay? So why don't you try check your understanding, not check your progress, but check your understanding 1 and 2, and then when you're done, come check your answer. Okay, for check your understanding 1, you should have gotten an obtuse triangle because there is one obtuse angle. Number 2, since all of them measured 60 degrees, they're all less than 90. That would make it an acute triangle, or more specifically, an equiangular triangle because all of the angles are equal. So moving on to example 2, the other way we classify triangles is by size. Okay? And if you look here at your book, how we classify triangles by sides, scalene triangles have all sides that have different measures, or another way of saying it is that no side is congruent to another. Okay? An isosceles triangle has at least 2 sides that are congruent. Okay? So here This side and this side are congruent, so that makes it isosceles. And then it is an equilateral triangle when all of the sides are congruent. The lateral part often with like lattice or side, and then equal, so equal side. Okay. So equilaterals, all sides are congruent. Okay. So here, looking at this picture, we're going to identify our types of triangles in the figure. Okay. So starting with our isosceles triangle, that's where two sides are the same. And so we have that here with triangle ABD, indicated by these two sides having the one tick mark. Okay. And then the other isosceles triangle we have is here, indicated because this side and this side has two tick marks. And so that is triangle BED. Okay. Scalene triangles have triangles where they're all different side lengths. Okay. So we have four of them, one here, one here, one here, and one here. So one is triangle ABC, triangle ACD, triangle BCE, and triangle CDE. And then here we can also see two bigger triangles. One is here, and the other one is here. They are also different side lengths, so then one of them is ABE, that's this bigger one here, and the one here, which is ADE. So here, why don't you try check your progress, 2A and 2B, and then come check your answer when you're done. So our equilateral triangle is triangle ABD here that I highlighted in pink. Equilateral because all the sides are the same with one tick mark here. And then 2B isosceles, at least two of them are the same as this triangle here, ACD, because AD and CD are congruent. Okay. So here's the next one with example 3. We're going to find x and the measure of each side of equilateral, so I mean all the sides are equal for this. Okay. So if all the sides are equal, I just need to pick two sides, any two sides work, and set them equal to each other. So let's do x plus 9 equals 2x. Okay. So I just set this side equal to this side. Okay. Subtract x on both sides. And then I get 9 equals 1x, so x equals 9. And then I just need to plug it in to see what each of them are. So 9 plus 9 here is 18. 2 times 9 is 18. 3 times 9 is 27, minus 9 is 18. And as you can see, this is also a good way to check your work. They are equal, which is why they're an equilateral triangle. Okay? So why don't you try CYP3, and then once you're done, come check your answer. Okay, what you should have gotten is x equals 3. Since it's isosceles, this side is equal to this side, okay, shown by the one tick mark here. And once I know x is 3, plug it in, so 4 times 3 is 12. 2 times 3 is 6, plus 6 is 12. As we can see, they are equal, which makes it isosceles, because two sides are equal. Okay, so last one here is we're going to be using the distance formula. So we're going to find the measure of the sides of triangle DEC, and then based on the length of each side, we're going to classify the triangle by sides. Okay, so I'm going to first start by finding the ordered pair for each one. So C here is 2, 2. D here is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, so 3, 9. Okay. And then E here is 1, 2, 3, 4, 5, 1, 2, 3, so negative 5, 3. So I'm going to find the distance of each side, so I'm going to do DC first. It doesn't matter which one I start with. Okay. So I'm going to do y2 minus y1 squared plus x2 minus x1 squared, and then square root it. Okay, so I'm going to start with the x's 3 minus 2 squared, okay, plus 9 minus 2 squared. Okay. 3 minus 2 squared is 1. 9 minus 2 squared is 7. 1 squared is 1. 7 squared is 49. And 1 plus 49 is 50. Right? Simplify my square root of 50. That is 5 square root of 2. Because 50 is 25 times 2. 25 is that perfect square. So that's the length of DC. Yep. Then I'm going to try the next one, CE. Okay. So CE, I'm going to do negative 5 minus 2 squared plus 3 minus 2 squared. Okay. Negative 5 minus 2 is negative 7. 3 minus 2 is 1. Negative 7 squared is 49. 1 squared is 1, so 49 plus 1 is 50, and square root of 50 is 5 squared of 2. So at least right now, I know that DC and CE are congruent because they are both a length of 5 squared of 2. Okay. So then my last side here is DE. Okay. So I'm going to do negative 5 minus 3 squared plus 3 minus 9 squared. Negative 5 minus 3 is negative 8. 3 minus 9 is negative 6. Negative 8 squared is 64. Negative 6 squared is 36. 64 plus 36 is 100. And when I square root 100, that gives me 10. Okay, so this side is not the same. Okay? But because I have two sides that are the same or congruent, that would make this an isosceles triangle. Yep. So why don't you try CYP4, and then when you're done, come check the answer. Okay, this is what you should have gotten. Because HJ and IJ, this is horizontal and this is vertical, I can just count the squares. So HJ is 3 units, IJ is 3 units. HI, because it's diagonal, I used the distance formula to figure out the distance. That gave me 3 square root of 2. And since there's only two sides that are the same, this is also an isosceles triangle. Okay. That's it for today. Have a great rest of the day. Bye, guys.